this session we will study about the types of relation. There are major types of relations. You look at here: universal relation, void relation, identity relation, reflexive relation, symmetric relation, antisymmetric relation, transitive relation, and equivalence relation. So I would like to explain you in detail about each type of relation. First we study about the universal relation. Let A be a set, then A cross A subset or equal to A cross A, and so it is a relation is called the universal relation on A. So here we see that we have a set A. We have the element 1, 2, 3 here, and we find a set A cross A as we have seen in our last session. It is 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. This is our A cross A, which is called the universal relation, because all the relations are there of each element. So it is called the universal relation. Now we study about the void relation. Let A be a set, then phi is subset or equal to A cross A, and so it is a relation on A. This relation is called the void or empty relation on set A. So we see how we get it. We have a set A. One, two, three, and we find a relation R which is empty. If I say that 1, 2 and 2, 4, here you see 4 does not belongs to A. Does not belongs to A. So this relation is void relation. This is called the void relation. If there is no relation is between among A cross A, this is not a subset of A cross A. So it is called the void relation. Now we study about the identity relation. In the identity relation, what we see that let A be a set, then the relation IA is equal to AA belongs to A on A is called the identity relation on A. In other words, a relation IA on A is called the identity relation if every element of A is related to itself only. It means if Y is equal to X is the way. If this is 1, Y is also 1, X is 1, Y is 1, X is 2, Y is 2, whatever the X is minus 1, Y is minus 1, in this way we get the relation, the same element over here. So I would like to explain here. Yes, we are putting here X or here Y. If I put here 1, we get 1, put here 2, we get 2, put here 3, we get 3. If we have a relation like A is equal to A is equal to 1, 2, 3. So we get the identity relation on A is 1, 1, 2, 2 and 3, 3. This is called the identity relation. So in other words, we have seen that A is called identity relation if every element of A is related to itself. So 1 to 1, 2 to 2 and 3 to 3. So this is called the identity relation. Now we study about the reflexive relation. A relation R on set A is said to be reflexive if every element of A is related to itself, thus R is reflexive. Implies that R for all A belongs to A. In other words, we could say that a relation R on set A is not a reflexive if there exists an element A belongs to A such that A does not belongs to R. So we see how it happens. One, 2, 3 is our set A. Or we have to find out the reflexive relation. We are denoted by R here. So it is 1, 1, 2, 2, 3, 3. Here may be other elements also. 1, 2 may be there, 2, 3 may be there. So this sort of set is called the reflexive relation. There are some elements may involve in this relation also, except this identity relations 1, 1, 2, 2, 3, 3. This should be there. If 1, 2, 3 is there and we have to find out the reflexive relation, so this is not a reflexive relation. I explain you how we recognize it is reflexive or not. So 1, we see that it is we have 1, 1, 2, 2, 1, 1, 2, 2, and there is 1, 2. So it is not a reflexive relation. It is not a reflexive relation. Why it is not a reflexive relation? I explain here. A relation R on set A is not a reflexive if there exists an element A belongs to A such that A does not belongs to A. So 3 belongs to A, but 3, 3 does not belongs to this R1. So it is not a reflexive relation. So this is the difference between a reflexive relation and not a reflexive relation. Now look at symmetric relation we study now. A relation R on set A is said to be symmetric relation if AB belongs to R and BA belongs to R for all AB belongs to A. In other words, we could say that A relation B is equal to B implies to B relation A for all AB belongs to A. So I explain you this. If we have a set A 1, 2, 3. We have a relation, symmetric relation R. It is 1, 2 and 2, 1 is there. So it is called the symmetric relation. 1, 2 and 2, 1 is here and both belongs to this A. This is called the symmetric relation. So in this way we could find out the symmetric relation 1, 2 and 2, 1. So this is a line of symmetry if we put here like this. So 1, 2 and 2, 1 is like a mirror image. So be there. Now friends, we study about the antisymmetric relation. Let A be any set. A relation R on set A is said to be antisymmetric relations if AB belongs to R, BA does not belongs to R, A is equal to B for all AB belongs to A. So it's very simple that if we put we have a 1, 2, 3. If a relation like this 1, 2 is there, 2, 3 is there, 1, 3 is there. So this is antisymmetric relation because there is 1, 2 but not 2, 1. 2, 3 there is not 3, 2. 1, 3 there is not 3, 1. So it is called the antisymmetric relation. Now friends, we study about the transitive relation. A relation R on set A is said to be transitive relation if AB belongs to R and BC belongs to R and AC also belongs to R for ABC belongs to A. In other words, we could say that A relation B and B relation C and also A relation C for all A, B, C belongs to R. Just like that, I give you an example. A is equal to 1, 2, 3. So, transitive relations means 1, 2, there is 2, 3. And 1 is 1 and 3. You know, 2 and 2 in both common here. So 1, 3 must be there. 1, 3. So this sort of relation is called the transitive relation. 1, 2, 2, 3 and 1, 3 must be there. So it is called the transitive relation. Now we see the equivalence relation. A relation R on set is said to be equivalence relation on A if it is reflexive, it is symmetric, it is transitive. So all the relations reflexive, symmetric, transitive is there, then it is called the equivalence relation. Just like if we have a set 1, 2, 3 and we see equivalence relation like we have 1, 1, we have 2, 2, we have 3, 3, then we have 1, 2 and 2, 1 is there. This relation you see, there is 1, 1, there is 2, 2, there is 3, 3, there is 1, 2 and 2, 1. So 1, 2, 2, 1 shows the symmetric relation and 1, 1, 2, 2, 3, 3 is a reflexive. So and the symmetric is, it is 1, 2 and 2, 1. So we have 1, 1 here. So it is transitive relation. So it is all the three sort of relations are there exist in this particular relation. So it is called the equivalence relation. So in this way we have seen that we have different sort of relations we have studied here. Universal relation we have seen, wide relation we have seen, identity relation, then reflexive relation, symmetric relation, antisymmetric relation, transitive relation, equivalence relation. We will do detail this because in our further sessions recording these are